Hello everyone, I wanted to kind of give you the rundown today of like what's covalent, what's ionic, what's hydrogen bond, what's dipole-dipole, what's London dispersion forces, or LDFs, they can also be called that for short. So to give you like the shortened version, covalent is when you have two nonmetals typically, like for example, carbon dioxide, carbon monoxide, a nitrile group, which is a C triple bonded to an N. Ionic is when you have like a metal and a non-metal. For example, the most famous example is table salt, NaCl, or sodium chloride. And then hydrogen bonds is usually what you see. It's what you see in water, right? So if you have two water molecules together, this water can interact with the other water and form a hydrogen bond. That oxygen can grab that hydrogen, and so on. This oxygen can also be attracted to that hydrogen. So it can be multiple going on at the same time. It's not like a one at a time process. And that's how, for example, even this is probably a little more advanced, but like when you think of solid and liquid and gas and the water for water, right? So when you're at the solid states, because you're forming 4 hydrogen bonds at one or average, right? And liquids are usually like 3 to 4, and then gaseous are less, obviously. And so that's kind of what I want to say with that, is that hydrogen bonds is not just like it forms one bond and then it forms another bond. No, this can be happening at the same time. Then for dipole-dipole, it's honestly these the dipole-dipole or the covalent or the ionic, there's a chart for it. So they're in the chemistry books. Usually it'll say, and it depends on the book, non-covalent. I think it'll say non-polar covalent or polar covalent or ionic. And I know that usually for ionic it's 1.5 up is ionic, and then if it's less than 0.5, it's usually non-polar. And then if you're in between, it'll say like 0.6 to 1.4 is polar covalent. You can look that up in your book, but I just wanted to let you know that if you're in between and you're like, well, what is it? You can check with the values. That's what I wanted to say with that. For dipole-dipole, it's usually like that you have a difference in the electronegativity values, and you can form a dipole. Hydrogen bond, the way that I was explained, is that it's an even more special type of dipole, because obviously it's going to just be oxygen and hydrogen, nitrogen, hydrogen, and fluorine and hydrogen. So my mnemonic for that is hydrogen bonds are on fleek. So I know it's cheesy, but hopefully it'll help you remember it's only oxygen, nitrogen, and fluorine. Going back to dipole-dipole, I gave you this example here that you have CCl4 and HBr. This chlorine can be attracted to that hydrogen and have a dipole. And London dispersion forces are just the weakest. It's just like two molecules bump into each other and there's no dipole. It's not that there's no dipole, but there's like a temporary dipole. It's a small bump. Like, it's not like dipole-dipole that it's a more permanent dipole. So for London, it's temporary just because of like how the molecules are interacting and moving at that time. It's like a temporary type of thing. And lastly, you guys know I love mnemonics and I love helping you guys. So if your chemistry professor is ever like, okay, rank these in order from the strongest to the least, see, I have done lots. And remember that these are the strongest and these are the weakest. Okay? And I hope you like this video. Please follow and share and check out my YouTube channel. Thank you.